Dear students, today let us discuss about the vector algebra, vectors. As you are already familiar in the physics chapter, vectors, in mathematics also you come across in detail a chapter, vector algebra. In vector algebra, it comprises mainly 4 chapters, which is divided into the very first one is addition of vectors. Second one is product of vectors. In the product of vectors, there are 2 chapters, sub-chapters. One is dot product or a scalar product. The second one is vector product. The last chapter is multiple product of vectors. In multiple product of vectors, we come across about scalar triple product, a vector triple product, a vector product of 4 vectors, and a scalar product of 4 vectors. And we come across some geometrical approach, applications of the vectors in a geometry. So this vector algebra comprises all this chapter. Today we shall discuss about a chapter, a vector algebra. That is, in that vector addition of vectors. Before getting into detailed discussion of addition of vectors, let us understand what is the basic definition of vectors and scalars. This vectors is the study of what? Mathematical systems. Is the study of what? Mathematical systems, especially while solving some problems, mathematical approach, especially in what? Geometry, mechanics, etc. This gives very easy method while doing the what? Problems. And what are the concepts you come across in vector algebra? Vector algebra, which comprises all the topics, what you study in the +2 level, what you study in the what? Intermediate level. So when you are preparing for what? Either mains exam or IIT exams or what? MCET exams, or on state level what? Engineering entrance examination oriented. So you have the syllabus which comprises vector addition, dot product, vector product, next multiple product of vectors. These applications we can apply in a large extent, even in what? Research oriented also we can apply. In vector algebra, we come across what all the topics you are going to study in the what? In this level. Vector algebra comprises calculus, vector algebra comprises algebra, vector algebra comprises geometry, vector algebra comprises trigonometry. Comprising of all in one forms a what? Vector algebra. So therefore, in any exams, you have more number of questions, more weightage you can find in what? Vectors, vector algebra. This is the fast developing chapter where you can find out a 3D approach. If you know the vector algebra, you can get easy approach, easy way of thinking in 3-dimensional geometry, 3D coordinate system, next DCS and DRS, next planes. This helps you to what? Think very quickly each and every concepts in a very depth way. So therefore, let us discuss about the basic definition as what? Vectors. So now vectors. First of all, vector. Yes, what is a vector? Vector is a physical quantity which is having both the magnitude and direction. What is that? Vector is a physical quantity which is having both the magnitude and direction. So therefore, now if I take, now look here, this is, now if I take A, if I take B, this is nothing but A bar. So therefore, this arrow mark represents a what? Direction, and the distance between A to B is taken as a magnitude. So therefore, every vector is denoted by a directed line segment. What is that? Every vector is denoted by a directed line segment. Segment, the distance between these 2 points, and directed, carrying a what? Arrow mark. So therefore, now this is denoted by either with this symbol, I can write AB bar or AB bar, arrow mark. Like this also you can write. You can also write. This represents what? Direction. Then what is its magnitude? So therefore, modulus of AB bar is equal to modulus of A bar. This is the magnitude. Now, I told this is a segment. For this vector, when this vector is denoted by a directed line segment, A is the initial point and B is the terminal point. What is A? Initial point and B is a terminal point. Then this vector A bar is denoted by a directed line segment. AB bar is equal to A bar. Now this is A bar or else arrow mark or else like this. Simply. So therefore its magnitude is what? Modulus of what? A bar. So therefore, what are the examples for a what? Vector. What I told vector, a vector is a physical quantity having both magnitude and direction. For example, force, velocity, acceleration, momentum, all this comes under the what? Etc. Comes under the what? Vectors, which is having both magnitude and direction. So therefore, hereafter every vector is denoted by a what? Directed line segment. I mean AB bar is equal to A bar, where A is the initial point and B is the what? Terminal point. So therefore, modulus of AB bar is equal to what? Modulus of A bar. Modulus of A bar. Next, now I go to definition of what? Scalars. What's the definition of scalar? The definition of scalar. Scalar is also a physical quantity, but having only magnitude. No direction. No direction. So therefore, now for example, mass, temperature, etc. Okay, it is having only magnitude, but no direction. So therefore, now I will write a scalar. What is scalar? A scalar is denoted by just by any real number. Any real number. So how to represent a scalar? A scalar is denoted by any real number k. Okay, k belongs to R, right? K belongs to R. Now, example I told, mass, temperature, distance, length. Now, if the distance between the two walls is 10 kilometers or 2 centimeters or 2 feet or okay, 2 meters, 2, 3, 4, 5, 6, all these are what? Real numbers. So therefore, now look at mass. Okay, mass of me. Okay, the weight, mass or a weight. The weight of me is what? 150 kilos. Do you agree? No. So the thing is what? The weight of me is 200 kilos. The mass of a what? This pen is a marker. Can you say 10 kilos? All this 10 kilos, 150 kilos, all this come out distance 2 meters, 10 meters, all this, it comes under the what? Real numbers, because it has no direction particularly. So therefore, every scalar is denoted by just a real number, and meanwhile a vector is denoted by what? Directed line segment. Directed line segment. Segment means length, directed means what? Direction. So therefore, now this is the difference between a scalar and a what? Vector. Scalar and a vector. So therefore, now we come across about two definitions. One is a vector, another is what? Scalar. What is vector once again? Vector is a physical quantity having both magnitude and direction. Scalar is a what? Physical quantity having only magnitude but no directions. So therefore, now every scalar is denoted by real number, every vector is denoted by what? Directed line segment. Yes. After knowing the what? Definition of what? That is a vector and a scalar, let us discuss about the classification of vectors, varieties of vectors. So therefore, types of vectors. So after knowing the types of vectors, we come across what? Null vector. What is that? Null vector. Yes. Null vector or a zero vector, the vector having its magnitude is equal to 0, but is having a direction. In null vector, initial point is same as terminal point. If I take this is A, therefore the null vector is denoted by AA bar or BB bar or MM bar or that is DD bar. Whenever, wherever, if you come across the vectors having a same initial point and terminal point, then those vectors are known as what? Null vectors. Null vectors. So therefore, null vector is denoted by what? 0 bar. So therefore, now the thing is what? Come on, this is the what? Null vector. So therefore, so now coming to this one is no fixed direction. No fixed direction. So it has a direction, but it is not defined. So therefore, AA bar, BB bar, MM bar, CC bar, DD bar are known as what? Null vector. What is null vector? The vector having 0 magnitude is called null vector and is denoted by O bar. Note, in null vector, initial point is same as terminal point, or else initial point coincides with the what? Terminal point. That is AA bar, BB bar, CC bar. Even though this definition looks very simple, but it is having its wide applications in vector additions. So therefore, now look here. Now null vector is a what? Vector. In a null vector, initial point is same as what? Terminal point. That is AA bar, BB bar, CC bar, and so on. Now I go for what? Like vectors. Two vectors, A bar and B bar, are said to be like vectors provided They must have the what? Same direction. Any vectors having the same direction, we can take them as what? Like vectors. Otherwise, they are unlike vectors. So therefore, say for example, I take AB is denoted by A bar. Now I take this is what? CD. I take this as what? B bar. Yes, I am not speaking about the magnitudes. Now I am focusing, I am giving the attention only on the what? Direction. A bar is equal to A bar, CD bar is equal to B bar, are the two vectors having the same direction. Then such vectors we call it as what? Like vectors. The vectors like vectors. Two vectors A bar comma B bar are said to be like vectors if they have same directions, same direction or directions, same directions. Otherwise, unlike vectors, that is, if I take like this, A, this is B, this is A bar. For AB bar, initial point is A, terminal point is B. If I go to this one is CD, for this is B bar. For this, now look here, now from here it is approaching. This is initial, this is terminal. So therefore, now such vectors we call it as what? Unlike vectors. Unlike vectors are nothing but what? Negative of a vector. A bar is in one direction, B bar is in what? Quite opposite direction. Such vectors we can also call it as what? Negative of a vector. Negative in terms of what? Directions. We are not worried about the magnitudes. It goes without saying, that is quite obvious. So therefore, such vectors, like vectors, are the vectors having the same directions. And same directions, if they have opposite directions, such vectors we call it as unlike vectors or negative of a vector. Now, we shall discuss about equal vectors and unequal vectors. Equal vectors. Right. The vectors A bar and B bar are said to be equal vectors if they have same direction and equal in magnitude Otherwise they are unequal vectors. Unequal vectors. I told two vectors what they are, A bar and B bar. Let us say this is A, this is B, this is A bar. Okay, this is A bar, this is what? B bar. Now I can say that's a CD. Yes, this is B bar. Modulus of AB bar is equal to modulus of CD bar. And directions of A bar and B bar are what? Same. Therefore, any two vectors are said to be equal. They must have the same directions and magnitudes are what? Equal. So, satisfying the two conditions, it is having its own advantage and applications. So, therefore, having the same directions and equal in magnitude, otherwise they are what? Unequal vectors. Now, not having the what? Equal magnitudes or different directions, right? So, therefore, any two vectors, any three vectors, take any number of vectors, maybe any number of vectors are said to be equal provided they must have to satisfy the what? Conditions, having the same directions and equal in magnitude. Otherwise, they are what? Unequal vectors, having a different direction or having different magnitudes. Yes, we come across about up to now 3 definitions, 4 definitions, starting with the what? Vectors. What is vector? Vector is a physical quantity having both magnitude and directions. For example, velocity, acceleration, momentum, etc., etc. And every vector is denoted by a directed line segment. Directed line segment means it must have a direction and you must have a what? Initial point and terminal point. Segment means distance between the 2 points. When you know the vector's definition, then we come across about a scalar. A scalar is also a physical quantity having only a magnitude but no direction. And every scalar is denoted by just a real number. Just a real number. So therefore, now that is scalar. Later, we come across about null vector. Null vector is a vector having what? 0 magnitude. Its direction is there, but it is not defined. Okay. So therefore, the thing is, in a null vector, it is denoted by 0 bar. And always in null vector, initial point always coincides with the terminal point or terminal point coincides with the initial point. For example, AA bar, BB bar, CC bar, DD bar, EE bar, and etc. Later, we went to what? Discuss what? Like vectors and unlike vectors. In like vectors, any two vectors, for example, we confined our attention only for 2 vectors. We can go for any number. So therefore, taking into consideration 2 vectors, A bar and B bar, when any 2 vectors, A bar and B bar, are said to be like vectors, we have taken into consideration only the directions. Okay, so when any 2 vectors are said to be like vectors having the same directions, otherwise they are what? Unlike vectors, negative of a vector. Then we went to discuss about equality of 2 vectors, equal vectors. The equality of any 2 vectors is defined only when having the same directions and equal in magnitude. Otherwise, they are what? Unequal vectors. Unequal vectors, as I told you. Yes. Now, let us discuss about the type of a vector, that is co-initial vector. Co-initial vector. Co-initial vectors. Co-initial vectors. Right. What is co-initial vectors? The vectors, 2 or more vectors having the same initial point. Such vectors, we call it as what? Co-initial vectors. So therefore, now say for example, If I take A, this is B. If I take C, if I take D, you can take what? E, right? All these are having the same initial point. That is AB bar, come on, AC bar, next AD bar, next what? AE bar, correct? All these vectors, etc., are known as what? Co-initial vectors. What I told? The vectors which are having same initial point are known as co-initial vectors. Co-initial vectors, right? Co-initial vectors. Now, let us make a move to understand what is that? Addition of vectors. It is one of the important definition in addition of vectors. So therefore, as in what? Vectors, we are under what? Addition of vectors. Addition of vectors. Addition of vectors. So, addition of vectors. When any two vectors A bar and B bar are said to be added or addition of any two vectors, addition of any two vectors is defined only when terminal point of the first vector coincides with the initial point of second vector. Now here, A bar and B bar are the two vectors. So therefore, now initial point of the second vector, that is any two, is addition of any two vectors is defined only when the terminal point of the first vector must coincide with the what? Initial point of the second vector. For example, I go for this. Now, A, B, C. So therefore, this is the first vector A bar. This is the vector B bar. Now, B is the terminal point of the first vector. Meanwhile, it acts as what? Initial point of the second vector. So therefore, when they coincide, then it forms a triangle. So therefore, in addition of vectors, by using vector treatment, how to add the two vectors? As you know in the common basic geometry, in right angle triangle we have a Pythagoras theorem. What is that? AC square is equal to AB square plus BC square. Here, so we cannot apply the common Pythagoras theorem for vectors. If we square vector, it becomes scalar. So therefore, alter, we have addition of vectors. So therefore, to add two vectors, to add 3 vectors. You can add any number of vectors, maybe n vectors. Okay, if you add what? N vectors, in that case, the condition is the terminal point of the first vector must coincide with the what? Initial point of the second vector. Initial point of the second vector. Then only the addition of vectors is defined. First of all, we confine our attention, or else let us focus our attention for the 2 vectors. Then we can go for any number of vectors. The first and foremost thing we have to concentrate on this is, so therefore, the terminal point of the first vector must coincide with the what? Initial point of the second vector. Therefore, this becomes A bar plus B bar. So now, as I told, I can write AC bar from figure. AC bar is equal to, I can write AB bar plus BC bar. Right? Terminal point of the first vector must coincide with the what? Initial point of the second vector. So therefore, now addition of vectors is also known as triangular law of addition. What is that? Triangular law of addition. So therefore, to become a triangle, this must coincide. Then it forms a triangle. So therefore, now this is for 2 vectors. You can go for any number of vectors. Therefore, AC bar is equal to AB bar plus BD bar. Now look here. Now not only for this figure, you can go for, say for example, this is the line segment. I take it for C. You can subdivide. This is D, this is E, this is F, and so on. Last one will be what? Z. We can also write BD, next what? DE, next EF, and so on. The last one is what? ZC. Therefore, the first and final point A and what? C. This is also, you can add any number of vectors. What I followed is the terminal point of the first vector must coincide with the what? Initial point of the second vector. Initial point of the second vector. So therefore, now this is called addition of any 2 vectors. Yes, addition of any 2 vectors is also known as triangular law of addition. I mean, any 2 vectors are said to be added provided the terminal point of the first vector must coincide with the initial point of the second vector. Now, vector addition. First one, vector addition satisfies the commutative law. Commutative law. Now what is that? This can be constructed as a parallelogram. Now commutative law is nothing but parallelogram law of addition. So therefore, now I take these 2 sides are parallel, means what? Equal. Therefore, you can call it as what? Equal vectors having same direction. These 2 are parallel. I can take A bar. You know that is law. That is A bar plus B bar is equal to B bar plus A bar. A bar plus B bar is equal to B bar plus A bar. So therefore, now let us prove this one is. What's the proof of this one is? It has its own advantage. Especially, you'll find more applications in geometrical applications. Geometry-oriented problems, you come across this application, commutative law. So therefore, now let AB bar is equal to A bar, BC bar is equal to B bar, be 2 vectors, be 2 vectors. Now from the figure you can very well observe. Meanwhile, now look here. Now AC bar is also A bar and AD bar is also B bar. You can take into granted. parallelogram is sum of two triangles. Therefore, from triangle ABC, AC is the what? Common diagonal. By using vector addition, AC bar is equal to A bar plus BC bar. I can write AC bar is equal to A bar plus B bar. You call it as 1, right? And next, from triangle ADC, AC bar can also be written as, by using vector addition, the terminal point of the first vector coincides with the initial point of the second vector. This is B bar, this is what? A bar, this is 2. From 1 and 2, yes, come on, A bar plus B bar is equal to B bar plus A bar. Hence, we can say that the vector addition satisfies commutative law. Vector addition satisfies commutative law.